Hey everyone, today I'm gonna discuss about Agent RTX, that is Agent with Runtime Experience. What is runtime? What is experience? So there has been constant debate about are agent memory actually helpful? Is the affected based retrieving what agents need to execute their task? The answer is no, and it's backed by leaders like Ram Harsha, the ex-CTO of Pinecone, that we have made wrong answers appear faster and cheaper, but we have actually made retrieval learnable. So this really resonated with us because we have been solving this for the past 3-4 months now, and we have a product called agentRTX, which I'll talk about in details. So let's get in and understand why agent memory sucks now. If you want to go into details, you can go to these blogs that I have written about memory, about runtime learning, or utility. These evidences that may not be agent memory might not be having solving all the problems. Like, has anyone actually solved the memory problem for agents yet? And this deals with different vector debate. What we think is it is because agent doesn't know what trajectory could lead to the right. That's how we came up with utility score. And the website is still called Reflect, but we are going to rebrand this agent RTX. So what we have seen is it performs really far much better than any other memory or RAG platform on agentic tasks, especially MEM0, our SOTA on Tau airline bench. So, I also want to talk a little bit about compile time versus runtime divides. So, compile time, like the SPI frameworks, are meant to optimize your prompt. But what we are doing with runtime is calling the exact context that the agent need to complete. So your context become task dependent, and it doesn't carry any other information that might not be needed to complete the task, and which reduces context stuffing, which is really good in this case. Why DSPy might not be thing? So this has been really well discussed at GitHub issue 9242 that it is not well with multi-turn trajectory. Why not? You can get into details and everything. I just want to show you how you could use it in your systems. Now let's see how easy it is to integrate it with your current stack. All you need to do is go down, install the skill, and ask your agent like Cursor or Codex to build, ask you certain questions about what framework you want to use, what observability and what evals you want to set, and just it also has smoke test if you need. One more thing that I wanted to cover is what does it actually show. So let's see run through. So here I'm trying to find a gaming mouse in my product SQL agent, and it returned I couldn't find any mouse. Let's go and see in the projects and get into the traces that, and it couldn't do it. So I mark it as failed. You can also use an LLM to give the right kind of reflections. And what's going to happen now is it built all these things. What tool it should have called, according to your reflection, what key mistakes it made in the past are things. But the most important thing is how it's scored for the task. Like the scoring mechanism has a RL layer completely built. So now if you ask, find me a gaming mouse, and it goes and search every other kind of mouse because I have already given it as an input that try to find other type of mouse that is available, and it recreates that trajectory. It recreates different trajectories. So
Just how easy it is to integrate agent with runtime experiences with Reflect. You literally do not have to do anything, and you get a lot of free credit. So you can just try it out, get skill, and then get your API and just get started. Uh, Along with this, you also get the past traces and some kind of observability, obviously. But the main thing is, it's all hinges upon a score that is being calculated all the time for what kind of context your agent need, for what kind of trajectory your agent should follow. I hope this video was helpful, and I'll see you again.